Hello guys, welcome back to 4 Into Tech. We are here today with another AWS project. In our last project, I have built a VPC, set up a public subnet, and also connected to the internet using Internet Gateway. So now it's time to take this project into the next level. Now in today's project, we are focusing on how traffic actually flows in and out of our VPC. And most importantly, how to control and secure it, right? Make sure that we have security in there. So in this project, I will walk you through how to use route tables and to direct network traffic, and also set up a security group to protect individual EC2 instance in case we created some inside, right? And we are going to use Network ACLs to secure the traffic in the subnet level. So I will explain everything in a simple and beginner-friendly way. Probably use some real life, analogy to help us understand exactly how this tool work together and manage, and make sure that we have secured our stuff that we have inside of our AWS network. Okay, so now I will definitely use also another diagram to explain exactly what we are building today. And before we jump into creating these route tables, I want to go ahead and start this project zero again. So we are going to build a VPC. Also after the VPC, we are going to build a public subnet and also create Internet Gateway. And from there, when we're done with those, now we are going to use the route table to direct the network traffic and then set up the security group and also use ACLs to secure the traffic. All right, let's go ahead and jump right into this diagram that I will explain how it works. And from there, when we're done, we are going to jump right into our AWS console to, start this project. All right, let's get it. All right, guys, here we are here in our diagram. As you can see here, we have the AWS cloud. This is the region that we are located. It depends on where you are. And then now on our first project, we have already created the region. So think of the region as overall like a location where everything is located, like everything is hosted like a city, for example, right? And inside that region, we have created a VPC, which is right here. As you can see, this is our VPC in blue. Okay, and think of the VPC as your own private space in the cloud, like a fenced property within the city. Okay, so that I'm pretty sure probably that make more sense to use those analogy to explain this. Okay, and then we have built a public subnet. So as you can see, this is the public subnet that we have right here. The public subnet is right here in green, and this is specific section in our VPC where it will place resources like our EC2 instance that we're going to create. If we create it, it's going to be inside that, and you can think of it like a room inside of your house that has access to the outside. Okay. So as you can see, now within our public subnet, we have our EC2 instance created inside. And then now inside that subnet, we have placed a security group. As you can see, the security group is right here in orange. And this is the security group, the security group going to act as like our personal security guard for our EC2 instance. Make sure the EC2 instance is well secured, right? And it controls the traffic is like who's allowed in and out of our instance directly. That's why we have the security group right here. Okay. So now that we're done with the security group, we have, for example, let's say we add the EC2 instance, that's like what I just explained right now. So, and then to connect everything to the internet, we have attached the internet gateway to the VPC as right here, what we have. We already built our last project. So this is the internet gateway right here. So to have internet here, we need the internet gateway where the outside traffic will come through this door right here, which is the internet gateway. Okay. And then now, with that being said, let's say, for example, you can think of the internet gateway as like you're installing a front door that allows communication between your house and the outside world. So this is the internet gateway that we have. This is where the traffic will come through. Okay. So now in today's project, we are adding our route tables. So we have our route table here. This is like a map that tells the subnet how to reach different destination. So we will make sure it knows how to reach the internet through the gateway. So for example, this is a map or like a GPS. Use it as a GPS where it will able to direct the traffic on like where to go. Like, if you use your GPS, if you want to go somewhere and you have a GPS, that GPS will serve you as like a way to learn exactly how to your direction, to your location. Okay. So the route table, that's what we're going to use it for. And then after the route table, we're going to add the network ACL. So this network ACL right here is like a security gate at our neighbor entrance. So it controls exactly the traffic in and out of the subnet. And as you can see, this is where we place it right here. So it's going to be controlling the traffic as coming in and out, okay, of the subnet. Okay. And basically that's why we have the network ACL right here. And then all of these pieces work together to make sure that the traffic follows the way it should. It's very secure and also very efficient. Okay, so this project basically helps us have a better understanding of how AWS handles networking and security beyond just getting things up and running. So it's about managing what comes in and what goes out and who is allowed through the door. Okay, so that's why we built this. That's why I built this diagram here to kind of give a little bit of explanation that what we are building. Is always good to have a visual, of stuff that we want to build. So this is a diagram right here. And then now that we're done with the diagram, let's go ahead and then jump into our AWS console where we're going to put everything together. So I'm going to start building everything from the ground. So I will start with our VPC and then build a public subnet. And when I'm done with the public subnet, I will build the internet gateway. And when we're done with the internet gateway, we are going to add our tables and then add the network. Before that, we add the security group first and then add the network ACL and to protect and our EC2 and then to know exactly how data flows in and out of our virtual private network and inside of our security group. All right. Now, before we jump into our console, let me just go ahead and then revise the definition of this different tool that we are going to use today. To start, we're going to start with the VPC. So a VPC is your private space in the AWS cloud. Think of it like owning a piece of land where you can build and control your own network environment, including like server, storage, and security, all isolated from others. That's the definition of a VPC and a little bit of analogy to explain exactly what is a VPC. And then now let's move to a public subnet. So a public subnet is a section of your VPC that has access to the internet. Resources like the EC2 instance placed here can send and receive traffic from the internet if properly configured. You can think of it like a room in your house with a window and door that can have access to the outside, So that's basically a public subnet. And then now when you talk about internet gateway, an internet gateway is what lets your VPC connect to the internet. It's like the front door that allows you to send and receive messages outside of your home. With your public subnet won't be able to truly be public because you cannot have access to the outside. Okay, so to be able to have access to the outside, the traffic go through the internet gateway. And then now when it comes to the route table, a route table is a set of rules that tells network traffic where to go. So basically help your subnet to know how to reach the internet through the internet gateway or probably other part of your VPC. It's like a GPS basically, and it kind of guides your traffic where to go. And then now we have a security group. A security group acts like a firewall for your EC2 instance. It controls what type of traffic can come in and out in each individual in each instance that you have there. It's like, for example, giving server its own personal bodyguard with a guest list, like who's allowed to come in and who's not allowed to come in. And now we have network ACL. ACL means access control list. So a network ACL is a border type of firewall that controls traffic at the subnet level, not just the instance, but at the subnet level. So it's like a security gate at the neighborhood entrance, checking every car before they get near your house. So those are basically the tools that we are using today. And I was like, let me just give again a definition of them before we jump into our console and start building this project. All right. Now that we are here in our AWS console, you want to go ahead and type VPC here, which is already have here. So you can type VPC here and then click on VPC. I'm going to make it very fast here because we already built this and then I already explained everything. So if you need more explanation, you can go ahead and I will put the link of my last video here. Then you can understand exactly, how to build a VPC and then all the explanation that I did. So now here, after you come to this page right here, they have a lot of stuff here, but you don't really have to worry about it. You can click on your VPC, and as you can see, we found here the default VPC that is already created by AWS. So I already explained that. So here you want to come in and click on create VPC, and then you can leave it at VPC only. So if you needed more service, you can come here, but as now we don't really need to touch this, so we can go back to VPC only and then create the name of our VPC. It will be called into tech VPC2. Let me name it VPC2. Okay, so as here we can leave it as IPv4 side the block. We already explained that, and here is going to be then the 6. Okay, all right, so we have the IPv4 side of block right here, and anything else we can leave it as it is, and then we can click on create VPC. There you go. So now we have our VPC created right here. So now let's go ahead and jump into the next. Okay, now the next step will be to create a subnet. Okay, so again, for subnet, there is 3 subnet that we found here. Those are the default subnet that AWS created. We don't have to worry about them. And just to make sure that you guys know, there is 2 types of subnet. There is a public and then a private subnet. Okay, so the private subnet basically is going to be whoever you give access to, you will have access to what's going on inside. And the public subnet is going to be something that everybody can see. Okay, so as you can see here, we want to click on create subnet, and then now it's asking you which VPC you want to select the subnet with. Okay, so now as you can see, we already have this one right here that we created, which is fall into tech VPC2. That's what we're going to choose. Okay, so that's the one that we need here to create the subnet. And also we need to give our subnet, our public subnet a name, and mine is going to be, let me just name it as Paul1. Okay, that's going to be the name of our public subnet. And then now we can move forward here. For the availability zone, we want to choose the one that the region that we are, which is Ohio. As you can see, we have Ohio here. And then now the IPv4 cyberblock, which is the range of IP that we have, we're going to leave this one as default because that's what we created. And then now we want to go ahead and then create another one. It's going to be 10.0.1. Sorry, that one 0, and it's going to be 24. Okay, so we already talked about this range right here. So again, if you need more information about it, you can go ahead and then watch the video that I made about this. Okay, everything looks good so far. So we have our IPv4, our subnet, public subnet setup. We have the IPv4 IP started, the CIDR block when it started and where it's end right here. So we have everything set up. We're going to click on create subnet. Okay, and wait a little bit. Now we have our subnet created. Okay, the next step here will be you're gonna select this, your subnet, your public subnet that you created, and then now you want to come here where it says action, and then go edit subnet settings. And then now you want to click on auto assign public IPv4 address. So basically what you're doing is you are saying that any EC2 instance that we have inside of this public subnet will automatically generate an IP address. So that's basically what we setting right now. So now when you're done, you want to go ahead and click on save. Okay, now that we're done setting up our VPC and then set up the public subnet, it's time to set up our internet gateway. And as you can see, we have our internet gateway here. So the internet, why we want to set up internet gateway, we want to make sure that the traffic that is outside of our AWS, we want to make sure that traffic can come through. But by coming through, the traffic need a door to get inside of our VPC. Okay, and they going to pass by our internet gateway. That's why we are going to create the internet gateway. And as you can see, we have a default internet gateway here. We don't have to touch it because this is the one that AWS created by default, and then now what we want to do next, we want to go ahead and click on create internet gateway. Okay, we can go ahead and then choose our name. So it's going to be for internet gateway. It's good for internet gateway, and then click on create internet gateway. There you go. So we have our internet gateway created here. All right, now that we are done creating internet gateway, the next step will be to attach this internet gateway to our VPC. And to do that, you want to come here where you say action. You want to click on action, and then you go to attach to VPC. And then now you're going to look up for your VPC, which is right here. So I'm going to click on that. And then next will be click on attach internet gateway. Okay, there you go. So now we have created our VPC, created our public subnet, created our internet gateway, and did attach the internet gateway into our VPC. Okay, so now we are done with that. Now we can go ahead and move into the next step. All right, now that we did create our internet gateway, and then we create everything that we needed. So now let's think of it as like if you create an EC2 instance inside of our public subnet, right? And then the EC2 is inside my public subnet, but so far our EC2 doesn't know exactly how to get into our internet gateway, so we are missing something here. And what we are missing right now is our route table. And then the route table is like the GPS, which is going to take the traffic coming outside of our VPC and then bring it inside of our EC2. So that GPS, which is the route table, knows the direction. So we're going to use that route table as a direction. Okay, so now the next step will be here to create our route table. All right, now that we are done with our internet gateway, it's time to move on into our next step, which is the route tables. Okay, and then the route table is the new step that we're going to learn here, because we already created our VPC, created our public subnet, and also create our internet gateway. So now it's time to jump into our route table. So as you can see here in our route table, we have two default route table that were created here. So now let's do some research. Let's do some digging here into these two route table that we found here. As you can see here, we have two route table that is already created here. As you can learn also from our first project that we did, AWS always created this default compartment just to help you kind of set up your AWS account. When you create an account, there is a lot of default services that is already set up just to let you kind of, move around inside the console and then create some stuff. So that's the reason why we have already these two route table that is created. So they are default route table. But now we can go ahead and try to understand these two route table that were created here by AWS. Right, to decode this route table that we have, these two that we have here. So if you click on the first one and then go click on route, it shows you that we have two route which is the first one is 0.0.0.0/0, and the target is EW, and the second route table here is 172.3.31.0.0/16, and the target is local. Okay, so now if you uncheck and then go to the second one and then go to route, it will give you that the route table that we have here is 10.0.0.0/16, and the target is local. Okay, so now let's go back to the first one a little bit and try to understand exactly what we have here. So now for the first one right here, as you can see, is a default route table that was created by AWS, okay? And it means that everything on the internet, it means like the 0.0 means everything on the internet. So the traffic going outside of the VPC, like accessing a website or updating software extra, goes through this route right here, which is this route that we have that was created. That was a default, okay? So the target here is the internet gateway, which give our subnet access to the internet. As you can see, this is our internet gateway right here, okay? So that's why we have the first one. And then now when it comes to the second one, which is the 172.31.0.0/16, it represents the default VPC CIDR block used by AWS when when our AWS account was created, okay? So when you don't create your own VPC, this is often like the default route table that was created for you to, have internet moving around your stuff that you have inside of your VPC, okay? And also, it means that the traffic designated within the VPC address space is allowed to move freely between instance and services inside the VPC. If you create the instance EC2 instance inside, so it means like the traffic that's going through them, this 172.31.0.0/16, and we have a local target. It means the traffic will be able to move around. So the local target is automatically added every route table. It's not removable, so it handles internal routing using your VPC. Okay, so in this case, the 172.31.0.0/16 represent the default on VPC CIDR block that what I was just explaining right now. So that's why we have these two right here. Okay, now let's go ahead and check the second route table here, the second one that we have. So let's uncheck and then check the first one and go to route. As you can see, we have the 10.0.0.0/16. If you guys remember, we already have this one created earlier, and the target is the local. Okay, so this CIDR block right here and was manually defined for our custom VPC that we created, and that's we choose this IP address early on. So in this case, just like before, AWS automatically added the local route to handle traffic within the VPC. So it allows communication between EC2 instance services and subnet inside your VPC, because we already created this VPC here. Okay, so now from here we know exactly why we have this one right here, which is within our VPC. Now we can go ahead and then create our new route table. We're not going to use this one. We're going to create a new one so we can, start adding our security group later on. As you can see here, we have in our route table here, we have the destination, but there is no other way for our internet that coming from our VPC to get out because we don't have a way to get it out. So now we need to create that way, that GPS, that destination, which is the new route table that we're going to create, that help our GPS to have interaction with the outside world. Okay, now to do that, we want to come here and then click where it say edit route. And as you can see, we already have the first one that we found there. So now we want to come and click on add a route. So now we're going to add a new one. As a destination, we're gonna use the same one, the one that it started the default, so we're gonna use that one. And then now for here is going to be internet gateway. Okay, so the target, we know the target, our target will be our internet gateway. And then now let's look for destination, the 4 internet gateway that we created. So this is the one that we have. So now we're going to click on that one. And then now we can go ahead and click on save changes. There you go. So now we have successfully added a new route. As you can see, we have it here. So we have the one that we just added. All right. So here I'm just going to do a quick summary here why we created this new route. So because our current custom route table only handles internal traffic, so it doesn't know exactly how to get out, right? So now to make it the traffic come out of our VPC, so now what we did was we created a new route table added to the one that we have, which was the destination was 0.0/16 and the target was internet gateway. So now that's why we created a new one. So the new one that we create now, it will give our internet gateway the opportunity to send traffic out of our VPC. Okay, so these are the fundamentals of AWS networking, and understanding them set the foundation. More advanced architecture later, it makes you understand exactly what you're doing. So that's the reason why I went ahead and then add a new route table and then kind of try to explain exactly why we needed that route table. Okay, now that the route table is created, it's time to associate our route table to our subnet. Okay, so now that's what we are going to do. So just to associate, that route table with our subnet, but let's just make sure to understand exactly what we are doing. So when you create a VPC, AWS give you a main route table by default, and any subnet you create is automatically linked to this main route table unless you do something else. And that's where explicit association comes in. So as you can see here, now we need to associate this route table into the subnet subnet in the VPC that we create. So that's what we're going to do now. And to have a better understanding of association, explicit association is just basically you are manually choosing a specific route table to be associated with. Think of it like if your subnet is like a room, and now route tables are like a map showing where the door leads. For the explicit association is you saying, hey, for this room, I want to use this specific map to get there, to get out. Okay, so that's basically what we're trying to do. What we're trying to do here, and why is important. By default, all the subnet use the main route table unless explicit told to use another one, unless you said another one, right? But when you are building a custom architecture like separating public and private subnet and using NAT gateway, you will often need different route table for different subnets. So that's when you go to route tables and then you want to go to subnet association tab and then add a new association there. So that's what we are going to do now. And then to set up the association, now you want to come here where it says subnet association. And then now, as you can see here, we have different information. This is the subnet that we have for one, and this is the subnet ID, and you have the IPv4 side of block here. And then to set up the association, you want to come here and then click edit subnet association. And then you select this one right here. And then when you select it, as you can see, it's already selected. And then now you want to come here and then click on save association. Okay. So now we are done with that one. Then now here, for a better understanding in our project, we created a public subnet and we wanted that subnet to use a route table that has a route to the internet via internet gateway. That's why we created our internet gateway. So what we did, we went to the custom route table, click on subnet association, which is bring us to that page, and then explicitly select our public subnet. And then so it follow the route rules for the internet access. So without explicit link, the subnet may still use like the main route table that AWS already created for us. And then now, which is have no internet access, and then now to be able to let that internet access, we have to associate it. So that's the reason why we went ahead and then create this association. Okay. So now we did that. The subnet association was a manual. We have to link it to our subnet route table that we created. And so now we have that one done is the way. So let's go ahead and jump into the next step. Right. Now that we are done with creating our route table, we just set up our VPC, create a subnet, public subnet, connected to internet gateway, and updated our route, with our own route tables. Now it's time to talk about security group. So in this step, we are going to create a security group. Think of as a virtual firewall that control who can talk to your EC2 instance and what your instance is allowed to talk to. If you are hosting a website or app and you want people to have access to the internet, you will need to open that specific port. That's exactly what security group help you manage. So in this part of this project, I will walk you through what security group does, and then how to create one, and how to set up a rule that allows safe traffic coming in and out of our environment. Okay, so now let's go ahead and then do that. And to do that, we want to come here in our security group where it says security group here, and then we click on security group. Okay, and as you can see, we have this default security group here. It's already set up like all the other services that we have. AWS already set up a default one for us. So all right, now when it comes to, for example, setting a security group for your cloud environment, and like I mentioned earlier, security group will act like, for example, a bodyguard for your EC2 instance. They check who is allowed in, and how they are trying to connect, and what kind of traffic is okay to let in. Okay, so now let's break it down into 2 key things that security really evaluate before they're letting inside of your environment. So first of all, we have the IP address, which is the source. So this tells the AWS where the request is coming from. So you can allow only specific IPs like your own computer, or range of IP using CIDR blocks, right? For example, the CIDR block that we have is started with 0.0.0.0/0 means allow traffic from anywhere in the world. And for example, if we use 192.168.1.0.24 means allow from only my internal network. Okay, that's just example. And now when we're done with the IP address, we can talk about protocol. And this protocol, they define exactly how data is being sent. So here are some common protocol that we use, or that we heard about, or we know. For example, TCP, which is a transmission control protocol and used for most of web traffic. And then we have the UDP, which is the user datagram protocol used for streaming, gaming, and real-time application. And then also another protocol that we know is the ICMP, which is Internet Control Message Protocol, used for things like ping command to check, like when you want to check a server and stuff like that, using the command like the command ping. And then now when you're done with the protocol, we can talk about port number. So this just kind of identify which type of service request is for, right? And here are some type of port that we're very familiar with, which is like port 22, which is for SSH. And, we have a port which is for our STP. And then port 443, which is for, the secure web traffic, which is the HTTPS. And also we have another port here we can mention, which is 3206, which is when it comes to database, SQL, stuff like that. And then also the port 53, we talk about the DNS. Okay. And now putting all together, when you create a security group rules, you are basically saying, I want to allow this IP address using this protocol to have access, to access this port number. Okay. So that's basically what you're setting when you're setting a security group. For example, we have another example here where you can say allow 0.0.0/0 using TCP port on 22. This means anyone can SSH into your server, which is not safe unless like you really know what you are doing. So those are basically, what our security group will be serving for us in our environment. Okay. All right. After learning all about those security group, or after trying to understand those, let's go ahead and then create our security group. Now, what you want to do, you want to come here and click on create security group, and you want to give it a name. So mine is going to be Fall in Tech Security Group. Okay, that's going to be the name for it. And we can add a description. The description will be going to be, I can type, okay, so the description of our security group will be a security group for Fall into Tech VPC. Okay, that's going to be the description of our security group. And then now we can go ahead and choose our VPC. So when you click here, this is the one Fall into Tech VPC2. So this is the one we need to associate with it. So we're going to click on that. All right, here we are going to set up a rule. So we have, as you can see, we have the inbound and outbound rules here. Okay, so now to make it a little bit understanding, so inbound rule means basically who can come into our environment. So the rules control incoming traffic to our instance. Think of like who's allowed to knock on my door and for what reason. Example, you have SSH, you have HTTP, and and then now the outbound is like what can go out there. So the rule control outgoing traffic from our instance and then to the internet or all the AWS resources. Think of like who can leave my house, or where is allowed to go. You know what I mean? So for example, you can start with our traffic, our IP that we have, which is 0.0.0.0/0. So your server can access the internet, download stuff like when it comes to connect to all the API if you need to. But basically, that's what allowed the outbound specific, IP or service for secure reason, That's why, so we're going to set up two rules here. So the outbound and then the inbound. Okay, to set up that rule, now we're going to come here, click on add rules. And then here is going to be HTTPS, okay? And then the source is going to be from anywhere. All right, so as you can see here, so we have this inbound rule, which is come from HTTP, well, from everywhere. And then the protocol is going to be TCP. The port range is going to be 80. The source is going to be anywhere, which is like this IP address here. As you can see, AWS will definitely warn you about are you sure you wanted to set up this rule, is here, but it's fine. You don't have to worry about it. So we can leave it as it is. And then now we can go ahead and then set up the outbound. So as you can see here, with the outbound, AWS already set up a rule for us, okay? So the inbound, we did set up what we wanted to set up, but outbound rules is set up by default by AWS, means like all traffic, all protocol, all range, and then you give you the custom, the IP that we have. So what does it mean? It means like this default outbound rules allow your EC2 instance or whatever's, security group is attached to your stuff. It can connect to the internet, they can, download software, update, connect API if they need to send data from any destination, either public or private IP and other AWS services, okay? So basically, your instance is allowing to initiate any kind of traffic to the outside world. So basically, that's what we have there into our default outbound. So we don't have to set up anything for the outbound here. All right, so with that being said, we can go ahead and then click here where it say create security group. And as you can see, give it a time, down it was successfully created. All right, now that we have created our security group, it's time to set up our network ACL. Think of like the network ACL, you can think of like the security fence at the neighborhood level. So while security group are like the logs and individual in the houses, and then the network ACL just protect the entire subnet, controlling what traffic can enter, leave, and that's why we need to create a network ACL. So a network ACL is just basically a firewall that controls traffic going in and out of, or in and out into your subnet, or like inside your VPC, so you can allow traffic or deny traffic. It's like stateless. So you have to set up manually to allow both inbound and outbound traffic separate, So that's why we are going to set up, which is our last part of this project, which is going to be our network ACL. So let's go ahead and set up our network ACL. And to do that, you want to come here, then you say network ACL, and then you click on network ACL. And then as you can see, we already have the default network ACL up there. So, all right, as you can see here, this is the network ACL that is really interesting. This one right here, the Paul one. So when you click on that, we can go ahead and then kind of check out what we have here. As you can see, we have all traffic allowed right here. And then, which is when it comes to the inbound, and then when it comes to the outbound also, we have all traffic allowed here. So that's basically what we needed into this network ACL that we have here. All right, as we needed to create a network ACL here, when you create a VPC in AWS, a default network ACL is automatically created with this default, which is allow inbound traffic and allow outbound traffic. As you can see here, when it comes to inbound, we have the number 100 all traffic here, and then this allow here. And then when you go to outbound, same thing. Okay, so basically a beginner level project like this one, where the goal is simply to understand traffic flow and to get out your EC2 instance and reach from the default network ACL is more than enough. So this one that AWS is created, so we don't need to create anything else. So the custom network ACL are used only when you want to be more, focused and then into the subnet level control. For example, allowing only specific IP addresses to come in, blocking certain port and creating different rules, or for example, subnets, right? So, but since the project is focused on learning the basic of traffic flow and security group and connectivity, we don't need to complicate much as like creating another ACL. This one, the default is working perfect for us. Okay, so now that brings out the end of this AWS project, network security project that we had. So in this project, we did create our own VPC, which is the virtual private cloud. We added a public subnet and then added internet gateway for our instance can reach the internet, and configured a route table to control traffic where it goes. And after that the route table, we did set up a security group to manage who can talk to our EC2 instance. And from there, we have explored network ACL, ACL, which AWS already created a set one that is default, and we're going to use that. So the goal was to see how traffic flows in and out the cloud and how security, it was laid, and then both the subnet and instance level. So now our instance to instance is in secure environment, and then it's accessible from the internet, and is protected by both the security group and then the default network ACL that we have. So this project is just, a strong next step after our first VPC building, and then now we did lay the foundation for more advanced network and security project in AWS, So now I cannot wait to see you guys into the next project that we have. And again, don't forget to delete all your whatever you created, because you want to be in the safe side. You don't want to AWS to charge you anything. Okay. So thank you guys for following along, and don't forget to like, share, and subscribe. And if this helped you to learn, and let's keep leveling up together. I can't wait to see you guys into my next project.